Hello guys, it's our new video and today we're gonna speak about different programming languages and we're gonna start with speaking about JavaScript. Misplaced trust in the clients, but first of all about the security of JavaScript. JavaScript and the DOM provide the potential for malicious authors to deliver scripts to run on a client computer via the web. Browser authors minimize this risk using two restrictions. First, scripts run in a sandbox in which they can only perform web-related actions, not general-purpose programming tasks like creating files. Second, scripts are constrained by the same origin policy. Scripts from one website do not have access to information such as username, passwords, or cookies sent to another site. Most JavaScript-related security bugs are breaches of either the same origin policy or the sandbox. There are subsets of general JavaScript and safe, secure ECMAScript that provide greater levels of security, especially on code created by third parties such as advertisements. Closing Toolkit is another project for safe embedding and isolation of third-party JavaScript and HTML. Content security policy is main intent method of ensuring that only trusted code is executed on a web page. Cross-site vulnerabilities. A common JavaScript related security problem is cross-site scripting, a violation of the same origin policy. XSS vulnerabilities occur when an attacker can cause target websites, such as an online banking website, to include a malicious script in the web page presented to a victim. The script is, in these examples, can then access the banking application with the privileges of the victims, potentially disclosing secret information on transferring money without the victim's authorization. A solution to XS vulnerability is to use HTML extracting whenever displaying untrusted data. Some browsers include partial protection against mm, potential disclosing secret information of transferring money without the victim's authorization. A solution to access vulnerabilities is to use HTML escaping whenever displaying entrusted data. Some browsers, including partial protection against reflex XSS attacks, in which the attackers provide an URL address, including malicious scripting. However, even users of those browsers are vulnerable to other XXS attacks, such as those where the malicious core is stored in a database. Only correct design of web applications on the server side can fully prevent XXS. XS vulnerabilities can also occur because of implementation mistakes by browser authors. Another cross-site vulnerability is to cross-site request forgery. In CS C let's see yeah CSRF code on an attacker's site tricks the victim's browser into taking actions the user did not intend at the target site. like transferring money at a bank when the target site rely solely on cookies for request authentication requests originating from the code on the attacker side can carry the same valid login credentials on the uh, interlink user. Uh, In general, the solution to CSRF is to require an authentication value in hidden form field and not only in the cookies. To authentication and requests uh, that might have lasting effects. Checking the HTTP reference header can also help. JavaScript hijacking is a type of TRF attack in which a script tag on an attacker's site employs a page of the victim site that returns private information such as JSON or JavaScript. Possible solutions include requiring an authentication token in the post and get parameters for any response that returns private information. Misplaced trust in the client. Developers of client-server applications must recognize that untrusted clients may be under the control of attackers. The application author cannot assume that their JavaScript code will run as intended or at all, because any secret embedded in the code could be extracted by a determined adversary. Some implications are website authors cannot perfectly conceal how their JavaScript operates because the raw source code must be sent to the client. The code can be obfuscated, but obfuscation can be reverse engineered. JavaScript form validation only provides convenience for users, not security. If a site verifies that the user agrees to its term of service or filters invalid characters out of the field that should only contain numbers, it must do so on the server, not only the client. Scripts can be selectively disabled so JavaScript cannot be relied on to prevent operations such as right-clicking on an image to save it. It is considered very bad practice to embed sensitive information such as password in JavaScript because it can be extracted by hackers and can be seriously attacked. So guys, that was all what I wanted to tell you for now. Thanks for watching, put your likes, and bye bye.